In the previous two videos, we've had a look at the way confidence interval can be constructed for a population mean given we are working with a large sample. And now let's have a look at the case when we've got a small sample. Similar to the case of large sample, we have two cases when we know population standard deviation and when we do not know population standard deviation. And if you look at these two formulas and compare them with the formulas for a large sample, you will see that they're almost identical with the exception of this t-value. So instead of having a z-score, we've got t-value. So this is another type of distribution. This variable follows another type of distribution. It's called t-distribution. And there is a special table, which I will show you in a second, that includes all the critical t-values. So to construct the confidence interval when we know the standard deviation, we need sample mean, we need the critical t-value for the significance level of alpha divided by 2, we need population standard deviation divided by the square root out of the sample size. And when we do not know population standard deviation, we will approximate it with sample standard deviation, and the rest of the formula, the rest of the confidence interval looks exactly the same. So as I've already mentioned, for this case we need t-value, and t-value is based on t-distribution, and on this slide you can see part of the table for the t-distribution. So if you check the first column, we've got something called degrees of freedom, which I will come back in the next slide, and here we've got the critical values. So for the t-value for 10%, for 5%, for 2.5%, for 1%, for 0.5%, for 0.1%, and 0.05%. So first we need to find the degrees of freedom, we need to define the level of significance, and then after this we can get the value from the table. So let's see what those degrees of freedom are. So to get the degrees of freedom, we need to take the sample size and subtract 1. So degrees of freedom is equal to n number of observations minus 1. And if you look at this graph, which compares z distribution, so normal distribution that we have in case of large sample, and t distribution, which we have in case of a small sample, you can see that with the increase in the degrees of freedom, we are getting closer to normal distribution. So the more observations you have, the closer you are to the normal distribution. So when degrees of freedom is equal to 4, we have a very flat distribution. However, when we have degrees of freedom of 20, the variability of the distribution gets smaller. So the distribution is itself steeper and is closer to the normal distribution. And similar to the case of large sample, this confidence interval has also got its own conditions. So first of all, a random sample must be selected from the target population, and this condition is the same as in case of a large sample. And we also need to make sure that the population has a distribution that is approximately normal. So this type of situation, when the mean value is in the middle and with the increase in the degrees of freedom, we are getting closer and closer to the normal distribution.